Now let's talk about geometric sequences a little bit more in detail. A few reminders is a geometric sequence is a sequence in which the same number is multiplied. We call that number the common ratio and we use the letter R. If the value of R is larger than 1, then your sequence will increase. If the value of R is between 0 and 1, it will decrease. And if the value of R is negative, then you will see your sequence go back and forth between increasing and decreasing because your numbers in your sequence, your terms, will be positive, then negative, positive, negative. If you can look at your sequence, you may be able to easily see what you're multiplying by, but if you can't, you can use the rule where you take any term and divide it by the previous term to find your common ratio. All geometric sequences are going to be discrete, like all sequences, but they are also exponential functions because you have a common ratio, which is like your base. We've already discussed the recursive rule. The recursive rule is given to you by a sub 1 equals, and you're going to fill in that number, the first term in the sequence, and then a sub n equals the common ratio times the previous term, which is a sub n minus 1. The closed rule is going to be used to find any sequence, any term, any specific part of the sequence that you want. And unlike the arithmetic sequence, you do not need to simplify. So here's your explicit rule. A sub n equals a sub 1 times r to the n minus 1. So you still need to fill in the first term and the common ratio, but you do not need to simplify. In the first example, we have the sequence 4, 20, 100, 500, and we are describing why it is geometric. In order for it to be geometric, you need to have a common ratio, so that means there needs to be a number that you are multiplying by repeatedly. You may be able to look at that and determine that you're multiplying by 5. If not, you can use the rule that says take a term and divide by the previous one. So if you take 20 and divide by 4, you'll get 5. If you take 100 and divide by 20, you get 5. 500 divided by 100 is 5. So it is geometric because the common ratio is 5. If it didn't have a common ratio, then it could not be geometric. So the first thing we're going to do is write our recursive rule, and that's when you have to provide the first term. So a sub 1 equals 4, and then any term is 5 times the previous term. So a sub n equals 5 times a sub n minus 1. The explicit or the closed rule is the one that I just gave you on the previous slide. A sub n equals a sub 1, which is 4, times r, the common ratio, which is 5, to the n minus 1. Make sure you do not simplify. Some of you are going to be tempted to do 4 times 5 and put 20 to the n minus 1, but that does not follow order of operations. You cannot multiply before you know the exponent. The last thing we're going to do is find a sub 8. So that means to find the 8th term. So one of the things that you could do to find the 8th term is just to keep multiplying by 5. I mean, we're already at 500, which is the 4th term. So if we multiplied by 5 a few more times, we would get to our 8th term pretty quickly. But I'm going to show you how to use the explicit rule, and all you need to do is plug in 8 for n because n is your index, and that's the term we're looking for. So 4 times 5 to the 8 minus 1. If you have a TI-36X Pro or a decent scientific calculator, you can type all of that in at once, but I'm going to show you how to do it piece by piece. So you're going to start with the exponent. You're going to do 4 times 5, and then 8 minus 1 is 7. Then you would do 5 to the 7th, which is 5 times 5, 7 times. That's going to be a large number. 78,125. And then you're going to do that by 4. And so you should get 312,500. What you're going to notice about your terms is they're either going to get large very quickly or small very quickly because, again, it is an exponential function. In example 2, it says find a sub 10 of the sequence 100,000, 50,000, 25,000, 12,500. A sub 10 means to find the 10th term. So we have two options. One is to just keep the pattern going. The other option is to use that explicit rule. So regardless of which option that you choose, you need to find the common ratio. So again, some of you may look at those numbers and say, oh, I'm multiplying by a half, or I'm multiplying by 0.5, and that's great if you can see it. But remember, if you cannot see it, take a term. So I always like to take the second term and divide by the previous term. Since the pattern is multiplication, to work backwards, we divide, and that gives you 1/2. Since 1/2 is a nice decimal of 0.5, I would be totally fine with you guys using 0.5 for this one. So if you want to use the recursive rule, that just means keep the pattern going. So you just keep multiplying by 1/2 or 0.5 until you get to the 10th term. Your other option is just to plug into the explicit rule. So I'm looking for a sub 10, a sub 1, which is 100,000, times the common ratio, 1/2 to the n, which is 10 minus 1. So again, if you've got a nice calculator, you can type that whole right side in all at once, or we can do this piece by piece. You definitely want to make sure that if you are using 1/2, you use the fraction feature on your calculator. So 10 minus 1 is 9. And so I am going to do 1/2 to the 9th power, which is going to be a fraction. So I've got 100,000. 1/2 to the 9th power is 1 over 512. And then I'm going to do 1 over 512 times 100,000, which is going to give me 3,125 over 16. I prefer you to leave your answers as fractions just because they tend to be more exact than decimals. But if you turn that to a decimal, it would be 195.3125, and I would expect you to put that entire decimal. For example 3, we're asked to graph the sequence modeled by a sub 1 equals 1/4, and then a sub n equals 4 times a sub n minus 1. This is the recursive rule. We know that because it has two parts. It gives us the first term and then the rule based on the previous term. So we know our first term is 1/4, so I'm going to go ahead and write that. And then any term is 4 times the previous term. So to get the second term, we're going to do 1/4 times 4, which is 1. Multiply by 4 and keep multiplying by 4. And so on. So to graph this, remember that we do the index versus the term. So the index of 1/4 is 1, so that's 1 1/4. That's going to be pretty much looking like it's going to be 1 0 because it's so small. The second term is 1, so that's 2 1. Again, pretty low. The third term is 4, so we're going to graph 3 4. The fourth term is 16. The fifth term is 64. And we're not going to be able to graph any more of those points. If you look at the shape of that graph, it certainly is starting off slow, but then growing very quickly. So we're asked what type of function this is. This is going to be an exponential function because you're multiplying by that common ratio, which is just like a base. Now, remember that all sequences are discrete, so you should not connect those points. And since they're discrete, when we go to do domain and range, we're going to be using our set notation, which means we're using braces, and we're going to be using ellipses because we've got an infinite sequence. So the domain corresponds with our index value, which is our position of every number. So all sequences have the same domain, 1, 2, 3, and so on. The only possible differences in a domain and a sequence is if you have a specific number of terms, you would end the domain with however many terms there are. The range are the actual terms. That's the 1/4, 1, 4, 16, 64, and so on. And they need to be in ascending order, which thankfully they already are. So we are just going to write out the first 3 terms and then use the ellipses. Make sure you always, use the ellipses and then use the brace. Make sure you always give at least 3 terms because that shows the pattern. Last thing we need to do is write the closed rule. That's the same thing as the explicit rule. So we have a sub n equals a sub 1, which is our first term of 1/4, times the common ratio, which is 4, and then to the n minus 1. Do not simplify. Now we are looking for the first term if we know the common ratio is 1/3 and the 7th term is 2. So like many problems, you have the choice of using the recursive rule or using the explicit rule. The recursive rule just means keep going or work backwards. So if we know the 7th term is 2, we could work backwards to find the first term. So that would mean you would multiply by 3 to get to the first term. And that wouldn't be too bad on this one since you have the 7th term, but if I gave you the 27th term, you probably wouldn't want to work backwards that many times, although you technically could. So what we're going to do is we are going to use that the explicit rule. So I'm just going to write it first, and then we're going to plug in what we know. So a sub n represents a term. They gave us a term. They gave us 2. A sub 1 represents that first term, which is what we're looking for. R is the common ratio, which is 1/3. N is the index, that's the position of the term they gave us, which they gave us the 7th term. And then minus 1. So now we've plugged in. All we have to do is solve for a sub 1. So to solve, you're going to start on that right side, and you're going to do 7 minus 1, which is 6. Now you're going to do 1/3 to the 6th power, which is going to be 1 over 729. So now we need to get rid of that 1 over 729. There are a couple ways you can look at this. In middle school, you started with talking about multiplying by the reciprocal, so that's technically what we're going to do. And then in one of our first units, I think it was unit 1, we talked about if you have a fraction to multiply by the least common denominator, which is 729. So what we're going to do is we're going to multiply 729 on both sides. And what that's going to do on the right side is 1 over 729 times 729 is just 1. And so that leaves you with a sub 1, or the first term. And then on the left side, 729 times 2 is going to give us our actual first term, which is 1,458. All right, for our last example, we are looking for the common ratio in a geometric sequence. We know that the 4th term is 108. So I'm actually going to kind of just draw a visual on this one. This one's a little bit harder to come up with how to do. Don't know the 5th term, don't know the 6th term, but we do know the 7th term is 2,916. So we did a problem similar to this with common difference where it was the same thing as finding slope. However, the common ratio is not slope, so we can't use that technique to find the common ratio. So what I want you to think about is you know the 4th term, you know the 7th term, and you know it is geometric. So that means we are multiplying by the common ratio. And I would have to multiply by it once to get from the 4th term to 5th term, a second time to get from the 5th to the 6th term, and then finally one more time to get from the 6th term to the 7th term. So essentially what we're doing is we're starting with 108, we're multiplying by the common ratio 3 times, and that should give us the 2,916. But instead of writing r times r times r, it'd be a lot easier if we just wrote 108r cubed equals 2,916. So now we're going to solve this. So first thing we're going to do is divide by our leading coefficient of 108. So that gives us r cubed equals 27. And then if you think back to one of our previous units, we worked on making sure we knew our basic cubes. And so what number multiplied by itself 3 times is 27? And that would be 3. So the common ratio is 3. And you can always check your answer, do 108 times 3 to see what that would give you. And I'll do it real quick. That would give you 324. And if you multiply by 3 again, you get 972. And if you multiply by 3 one more time, you would end with 2,916. So some students actually like to just guess and check until they find the right common ratio on this, which technically would work.